As Sean spoke about on Monday, he gave you the background of all the work we've been doing basically with Cyclurocalli, the Jamaican iguana. So basically, it was declared extinct in the 40s. In the 70s and in the 90s, we found it again. And since then, we've been trying to help it to recover. So that's the basic idea that you need to remember. So just some objectives of specifically the past 4 or so years under this particular project. Our primary objectives have been, first of all, invasive predator control. Secondly, protecting and monitoring known nesting sites, because there are so few of them, so few soil patches in the Hellshire Hills, which you heard about from Sean again. We do need to try to make sure that all of those areas are monitored and protected as much as they can be. And Head Start release, and I'll tell you more about all of these later on. Our additional objectives for the project are quite numerous. I actually had to combine some and edit them so that they wouldn't fill up too many slides. But we do conduct some genetic analyses, so we collect DNA samples from all our hatchlings. We do try to locate new iguana nesting sites wherever we can, so we do surveys throughout the hills. We have annual pitfall trap surveys, so I'll tell you about that later. One major aspect of the project was supposed to be the Goat Islands Rehabilitation Project, but most of you know about the concerns with that. We do coastline monitoring of the target forest. We have a forest ecology project going on, field station maintenance. We do have a field station up there. Mark recapture studies to figure out distribution and camera trapping. So starting off with our invasive predator trapping. For the period that we've been under this particular project, we've caught 426 mongooses, 33 cats, 53 pigs. The major aim is to catch mongooses. So we have specific traps up there baited with red herring. I'll tell you more about those traps. And that number has been increasing over time. And that is specifically because we've been expanding our trapping grid, which I'll also mention more about later. So as far as the expansion of the trapping grid goes, basically, let me tell you about it with the diagram. So this is our original grid here, our original loop. So we have these metal box traps baited with red herring, as I mentioned. Mongoose walks in, trap closes, he can't come back out. We exterminate the problem. So this blue loop here is our original trapping loop, and this yellow loop here is our expanded trapping loop. So as far as the expansion goes, how far we've got so far is that the western half of the loop has been completed. The eastern half of the loop is currently in the process of completion. So we just have a few more traps left to open. So basically what we're trying to do is we're trying to monitor or protect, actually, the nesting sites and the individual populations that we know about. So all of these polygons here are new populations that we haven't yet been protecting with our current loop. And these pins that you're seeing here are the existing nesting sites that we have been monitoring for all these years. So that's basically the idea of why we expanded the trapping loop. And just some justification for the trapping. We have seen a high rate of nest success within the predator-controlled areas and a very low rate of nest success outside of the trapping areas. So of the 53 nests that we identified last year, within the protected areas, there was about 80% or 90% survival of hatchlings. However, of the 14 nests that we know of outside of the trapping areas, there was 0% nest success. All of them were predated by mongoose as far as we've seen. So we do know that the trapping does help the survival of hatchlings. So this graph here is showing you how the number of nesting females has increased over time since we started the project. You'll see a little bar here for 1991, and then it starts at 2004. Our initial estimates are from when... Whoa, that's not supposed to happen. It's doing that by itself, I swear. Okay, so our initial estimates that we have are from when we had our second rediscovery in the early 90s. So back then we found that there were about 9 nesters. So we saw about 6 females actually digging nests, and we saw about 2 or 3 more gravid females that we assumed were going to nest as well. So as you can see, we'd like to think from our efforts we've been seeing an increase in the number of nesting females until last year we actually saw 53 nesting females, and that was actually a record for our project. So over the life of the invasive alien species project specifically, we've seen 144 confirmed nests between the major nesting areas, upper nesting site, lower nesting site. As I mentioned, there were 53 nesting females last year. That was a 6-fold increase from 1991 and a 2-fold increase from when we first started this project started on this project in 2010. The problem with our high rate of nesting success is that when you only have a few patches of soil for the iguanas to dig their nests, you have sort of out competition. And rock iguanas tend to be very aggressive. So when the females are going to dig their nest, they don't have any problem with fighting off another female, digging up her nest and laying their own eggs there. So we have started the construction of artificial nesting sites. This is our first major one that was completed in 2012. And 2 successful nests were actually laid in it last year. So hopefully they'll use it even more this year for nesting, which is between April and June. So for protecting and monitoring our nesting sites, that's mainly, well, we monitor it during nesting as well, but this nest site surround is what we build when hatching season comes along. So that's in September. When the babies are coming out, they're more susceptible to mongoose predation. So we basically erect this tarp structure, and we go in, we catch the hatchlings that we see coming out. We essentially get DNA samples, we tag them, and then we release them. For hatching seasons under this project again, we've seen about 958 hatchlings. And again, all of them were sampled for DNA. 170 were brought back to the Hope Zoo in Kingston for the Head Starting program. That's about 40, around 40 per year. 320 were actually collected and processed last year, which is a huge rise from our original record in 2010, which was 219. So over time, we are seeing more and more success, and that's just a graph showing you basically everything I just said. So head starting and repatriation. This is a major component of the project. Essentially, as I mentioned, we take around 40 hatchlings every year to the Hope Zoo. We feed them, we allow them to grow in captivity for a while. The idea is that we're protecting them from the predators. So there are over 200 individuals at the Hope Zoo right now in our Head Start program. And then once they're at a size that we believe that they can defend themselves against mongoose especially, we bring them back to Hellshaw and we release them. So over the period of this, of the Invasive Alien Species Project, we've released about 88 Head Starters. This year we released 29, we just did that a few weeks ago. And 52 were actually released last year, which was a huge record for us. So overall, up to the end of this particular project last year, the total was 226. Right now, the total stands at 255. And that's just a picture of Prof. Wilson's son there standing with all the iguanas ready to be released. That was when we were releasing the historic 200th iguana into Hellshaw. All right, so for our genetic samples, we take samples from essentially all the hatchlings that we catch, and as well, if we can, if we do catch individuals during the nesting period or in the metal mongoose traps by accident, we try to take samples from them as well, if we can. And those samples are all sent to Mississippi State University, where they're currently doing genetic analyses. Ahmed Raspberry, he's working on his graduate project on that. But basically what we've been finding is that the rate of inbreeding is actually decreasing. And about 95% of the genetic variation that existed in the original population that we found in the 90s is still there. So we know that with growth in population size, you have less of a chance of, less of a chance of a decrease in genetic variation. Part of the reason that we really wanted to do the Goat Islands project is so that we could increase even further this genetic variation and decrease even further the likelihood of inbreeding. But you know, these things happen. So the pitfall trap surveys. This is actually my PhD project. We have data from 1997. Essentially, we have these buckets that are submerged in the ground in Hellshire, wherever we can find a soil patch. There are actually four of these trap grids running along from our south camp. It's a joint project with the Department of Physics, which I am actually a member of. So we actually installed a weather station up there. We're tracking the climatology of the area. So far, we know that it follows all the basic patterns of what a dry forest is expected to do. And we're using that data to actually model what the effects of climate change will be on the forest itself, and specifically on the abundance of the fauna there. And to show you an idea of some of the results that we're getting so far, these are actually graphs showing you the change in abundance of a particular cricket with climate variables. So on my right here, you'll see the blue line is abundance and the red line is rainfall. And on the left, you'll see blue line abundance, red line temperature. So you can kind of see a relationship between the two. It really likes high amounts of rainfall, or it works well with rainfall. It doesn't really work so well with higher temperatures. So we know that we can actually identify a climate signal in the populations that are there. And the other point of the pitfall trapping surveys is that we actually want to see what is happening to these smaller vertebrates and insects in the predator control zone and what's happening to them outside of the predator control zone. That's going to give us kind of an index of what the mongoose activity specifically is like between the two. As I mentioned, one of the biggest points of things that we've been driving for recently has been the Goat Islands Rehabilitation Project to, as Sean mentioned, introduce a satellite population on the Goat Islands. This is actually Hellshire proper right here. It's a gorgeous picture. This is a crocodile pond. Up there where I can't reach is actually Goat Islands in the distance. Gorgeous islands. But we all kind of have an idea of what's been going on with that. We're not completely sure what the situation is, but right now we know it's probably not going to happen. But we still hold out hope. However, we have conducted botanical surveys between Hellshire and the Goat Islands. That was a major accomplishment. We added over 140 new species of plants to essentially the list of plants that are existing in Hellshire now. And a lot of those endemic plants that we found are also actually on Goat Island. So we do know that the flora there is not as degraded as we would have thought by goat activity. And we do know that the things that the iguanas like to eat are still there. So we have, as I mentioned, a forest structure and regeneration project going on. Another PhD student, Adit Sharma, he is actually looking at the different functional types that are in the vegetation there, and basically looking at how they change with deforestation and climate change. So he basically has a bunch of laid out plots in Hellshire, and he measures every single tree, every single seedling in all of those plots. It does take a while, and it is back-breaking work, but he does it. Our field station. So that's our field station right there. It's our cozy little hotel in the middle of Hellshire. It sort of serves two purposes. First of all, it's a nice base for our research. So if we're checking the mongoose loops, pitfall traps, basically anything we're doing in Hellshire, we have a place, jumping off point, essentially. The other thing it does is that it allows for constant human presence, or at least relatively consistent human presence in the hills, because we do have a problem with charcoal burners, crabbers, other people essentially coming into the hills every now and then. So if they know someone is there, they're less likely to come in. Iguana distribution surveys. That's one of the most important things that we're doing right now. We captured around over 600 iguanas over the period of this project, and the surveys go hand in hand with camera trapping images, which essentially help us to figure out the most important activities of the Jamaican iguana. And there are two Jamaican iguanas going on with some wonderful population expansion right there. There are some conies playing on a crocodile nest. So we see not only iguanas, but other endemics and its main predators. That's a mongoose actually walking out of an iguana nest with an iguana egg. So we're actually catching them in the act. We're not just guessing that they're doing it. Coastline monitoring, that's done both by foot and with camera traps. So we actually walk along to check crocodile nests and so on. And that's a mongoose scent marking a crocodile egg. However, there are still lingering conservation challenges, which is why there was that question mark after recovery in my title. So the three original major conservation challenges that were identified when we rediscovered the iguana were the invasive predators, charcoal burning, and large-scale development. We've kind of been controlling the invasive so far, and large-scale development. It is sort of infringing on the borders of Hellshaw, but the major thing, and especially, go to islands again, but the major thing has been charcoal burning. So this is actually an active charcoal burning area in eastern Hellshaw. That's one in central Hellshaw, which is actually the core iguana zone. And from this map here, so this is Hellshaw. This is our main set of nesting sites here, and as you saw from the loops that I showed you before, all of our nesting sites that we're monitoring are basically in this area. And this is just one of the active charcoal burning zones that we've found closest to our nesting sites. So they're actually burning within the core iguana area. So that's removing, not only disturbing the iguanas, just disturbing their peace and safety, but they're actually removing habitat. So we have quite a few publications there. One of the major things last year, we had a wonderful symposium. We had the Iguana Specialist Group meeting in Kingston. A lot of discussion came out of that, and we are making plans now of how we can move on to help with the recovery of the Jamaican iguana. And a lot of projects are kind of coming into place, or we're trying to think of ways to deal with our conservation challenges, especially charcoal burning. So, thank you.